Assalamualaikum warahmatullahi wabarakatuh, and hello dear students. So in this video we will learn about 1.2 three-dimensional coordinate system. So by the end of this video you should be able to plot a point in 3D, sketch a box or surface, and find the distance between two points in 3D. So this is basically a three-dimensional coordinate system in which you will have 8 octane. Okay, the first octane is where your x-axis, y-axis, and z-axis always be positive. Okay, what is x-axis, y-axis, and z-axis? Let me show you. Okay, so basically you draw your three-dimensional coordinate system like this. This is your x-axis, y-axis, and z-axis. Okay, so if this is the positive x-axis, then behind there will be your negative x-axis, and if this is the positive y-axis, and to your left is the negative y-axis. And also this one, if this is your z positive, z-axis positive, then below will be the negative part. Okay, so this area is your first octane, and then you will read the octane counterclockwise, the same as if you have two-dimensional coordinate system. Okay, this is your x, this is your y, this is your x positive, this is your y positive, then the area where your x and y positive is your first quadrant. Okay, this is what we call first quadrant. And the next is counterclockwise, second, third, and fourth. Okay, so in three-dimensional coordinate system will be exactly the same. First octane, and then second octane, and then the third octane here, and then the fourth octane is here, and then repeat below. Okay, the fifth will be below first, the sixth will be below second, the seventh will be below third, and the eighth will be below fourth. So we will have 8 octane altogether in a three-dimensional coordinate system. Okay, so you have known the axis, x, y, and z, the positive, negative, and the octane. Now we are going for our first objective, which is to plot a point. Okay, how do we plot a point in three-dimensional coordinate system? Okay, so let's say we are trying to plot all these 4 points, 1, 2, 3, negative 1, 2, 3, 1, negative 2, 3, and 1, 2, negative 3. In the same three-dimensional coordinate system. Okay, the first one, let's say this is 1, this is 2, this is 3. Okay, remember we are trying to plot a point. Okay, so the point in the z-axis, you draw a line parallel to y-axis. Okay, and the point on the y-axis, you draw a line parallel to x-axis. Okay, so this is the base tapak dia, tapak. Okay, and then you bring up until z equals to 3. So this is will be 1, 2, 3. The first point. The second point, okay, let me use a different color for the second point. So let's say this is your negative 1, 2 already here, 3 already there. Okay, again, okay, so your second point somewhere here, negative 1, 2, 3. Okay, using the same technique, we will plot the third point, which is 1, negative 2, 3. Negative 2 means your y is here, negative 2. Okay, so draw a line parallel to y, draw another line parallel to x, and then this is will be your base. Okay, and then bring it upward. Okay, so this will be 1, negative 2, 3. Okay, make sure this parallel. Okay, so as this, so as to this one. Okay, let us plot the last point, which is 1, 2, negative 3. Negative 3 is where your z equals to negative. Let's say here, negative 3. So you already have 1, 2 here. Okay, so make sure it's parallel. You bring it downward. So this is your 1, 2, negative 3 point. So you have all your 4 points there. Okay. Okay, let us look into this first example. Example 1.2.1. Sketch a box in the first octane of length 3 and has the origin as one of its vertex. Okay, so this is the answer. How do you get the answer? So for example, if I have sketch a box like this one, first I draw my three-dimensional coordinate system, and then length 3 means x is 3, y is 3, z also 3, and has origin as one of its vertex. So origin is one of its vertex. Then okay, again from the x-axis you bring parallel to y-axis. Y-axis, draw a line parallel to x-axis. Okay, and then this one also, this one as well. Okay, okay, how about this one? Okay, just bring something like this, so you have a box. Okay, so exactly you can plot you can know each point in this box. For example, this answer give you 3, 3, 3. Let's say I want to plot this point. Okay, this point is 3, 0, 0. This point is where 0, 3, 0. Only y-axis has a value. This point on the z-axis has a value, so it is become 0, 0, 3. This one is already been given 3, 3, 3. Let's say I want to plot this one. Okay, so x is 3 here, x is 3, y, no y, okay, y is 0, and then z, z also 3. So this one is 3, 0, 3. And then this point is x is 3, y also 3, and z is 0. So basically you have to know how to plot a point given a coordinate, and you have to know how to read a coordinate given a point. Okay, let's look into this second example. Sketch a box in the second octane having the length, width and height 3, 2 and 4 respectively, having origin and negative 3, 2, 4 as two of its vertex. So this is the answer. So how do you get the answer? Let's say, okay, we draw our three-dimensional coordinate system first. Okay, let's say the length, height 3, length is x, width is y, and then this height is z. So length will be 3, and then it's already set here, it one in second octane. Second octane, where is your x negative? So instead of plotting 3 here, you should plot negative 3 here. Okay, and then y is 2 and z is 4. Okay, and then having origin and -3 to 4, -3 here, okay, to here. Okay, this is -3 to 4 points of its vertex. So I can already plot a line here, and then this one as well. Okay, this one as well, this one as well. Okay, so you have a box like that. So I already know this is -3 to 4. This one is the origin, so it will be 0, 0, 0 origin. This one is on the y-axis only, so it will be 0 to 0. This one is on the x-axis, which is -3, 0, 0. And then this one is on the z-axis, which is 0, 0, 4. And okay, let's say this one. Okay, on the x equals to 0, y equals to 2, and then z equals to 4. Okay, so now we will look into the difference in 1D, 2D and 3D. Okay, let me show you in detail. Okay, let's see one-dimensional coordinate system, two-dimensional coordinate system and three-dimensional coordinate system, the difference of each system. So in 1D you only have a number line, what we call a number line. Okay, in 2D you have a xy axis, or we call xy plane. Some book call it a Cartesian coordinate as well. Okay, or it is a two-dimensional coordinate system. So in 3D, what we have learned in this topic is you have x, y and z, three axes. Okay, so let's say I want to plot a x equals to 3. X equals to 3. In one-dimensional coordinate system, x equals to 3 is only a point of x equals to 3. In two-dimensional coordinate system, if you want to plot x equals to 3, x equals to 3 will be a line. Okay, because in 2D, when x equals to 3 means your y is arbitrary. Arbitrary means y can take any value from negative to positive. So in 3D, if my x equals to 3, I have two other variables which will be arbitrary, and they are y and z. So when I have x equals to 3, my y can take any value, my z also can take any value. So what you have is actually a plane. Okay, so in one-dimensional coordinate system, you will have a point. In two-dimensional coordinate system, you will have a line, whereby in three-dimensional coordinate system, you will have a plane for the same function x equals to 3. Okay, how about if I have y equals to x? How do I plot y equals to x in 2D as well as 3D? Okay, so you have known that this is a linear function in which in 2D we will plot something like this, y equals to x. Okay, so again in 3D you have x, y and z. However, in your function you only have y, x and y. How about z? Then z is what we call arbitrary. It can take any value of z. So y equals to x is this line, y equals to x. Okay, but then this line can take any value of z. So it can be positive z until negative z. So we will have a plane, something like this. Okay, you cannot plot y equals to x in 1D because 1D only consists of one variable, x. Okay, so let's see more examples on how to sketch a surface or planes in 3D. Okay, so we want to sketch in 3D, three-dimensional coordinate system. So again, we only have x equals to 4, y and z has arbitrary value, so plot a line along y-axis, another line along z-axis. So this is your what we call plane on x equals to 4. Okay, B, z equals to 5. Let's say here is z, your z equals to 5, means your x and y is arbitrary now. So just draw a line along y-axis, another line along your x-axis. Okay, and then this will be your plane on z equals to 5. So you can imagine like you have a plane floated on z equals to 5. Okay, a plane floated on z equals to 5. You can imagine that. Okay, let's look into C. X plus y equals to 2. Okay, x plus y equals to 2. How do you sketch x plus y equals to 2 in 2D first? Let's say we want to sketch it in 2D. So y equals to negative x plus 2. So if something like this, okay? So when y equals to 0, your x equals to 2. When your x equals to 0, your y also equals to 2. So let me transform this into 3D. So we will have a line across x equals to 2 and y equals to 2, right? And again, our z will be arbitrary. So this line is along z-axis, positive and negative. So we have a plane of like this. Okay, so if you cannot imagine directly in 3D, you transform the sketching from your 2D to 3D. Lastly, let's see 3x plus z equals to 6. Okay, so when my x equals to 0, my z will be 6. When my z equals to 0, my x will be equals to 2. So I have a line like this. And then again, my line will be along y-axis. Because I have no value of y, means my y will be arbitrary. Okay? Okay, our last objective is to calculate the distance between 2 points in three-dimensional coordinate system. So this will be the last topic in 1.2. For example, if I have a question, find the distance between point 2, -17 and 1, -5. Okay, I just use this formula. So actually this formula is an extended formula from two-dimensional coordinate system. If two-dimensional coordinate system, you only have x2 minus x1 plus y2 minus y1 square root. But now you have another variable which is z, because in 3D you have x, y and z. Okay, so you just do like this. Let's say this is your x1, y1, z1, and then this is your x2, y2, z2. Okay, or you can change. This one will become your x1, y1, z1, and this one will become your x2, y2, z2. Also can, because the formula is squared. Okay, so any negative value will be positive. Then you have this one. So I think there will be no problem for you to follow this one because it is only a formula type. Okay, so thank you for listening to this video. This is the end of this video for three-dimensional coordinate system. Please do all the exercises in column and do ask your lecturer if you require further information or if you have any more questions regarding this topic. Thank you.